Hello and welcome to our next session where we can continue our discussion on scaling and symmetry and transformations. Now, last time I asked that you look at, if you want to, look at exercise 12.6, where we just look at all the different combinations of what information can be given, what information I might need to find, and how I would do that. So it's important to sort of have a big picture, a little overview of how these things are connected, what I need to be able to do. Yes, they can hide this in a wordy problem, but essentially it's going to be the same. So in exercise 12.6, we just sort of break it down into the essentials of what information could be given. And what I need to find is pretty much everything else. Page here, and we will get started. Very slow to react. There we go. Okay. So I won't necessarily do this in a table. I'll try and preserve the table, but if I need more space, I'll take more space. So let's call it number 1, 2, 3, and 4. So I'll make my table here. We have the length or scale factor. To do it like that, it's fine. And in this case, they give me that, and that is what I will call K. Then I need to find all the other things. Now, I don't have to do it in this order. The percentage change I can interpret from the scale factor. I guess I'll say here the length dimension percentage change will be an increase by 20%, right? So I'm looking at how I travel in this factor from my base 1. I'm going up by 0.2. The percentage equivalent of 0.2 is 20%. Okay, so that is everything, pretty much, regarding the length dimension. Then I want to know by what factor does the area increase? That's going to be k squared. Now, because that's a 12, I can do it in my head and get 1.44. I think we've seen this one before. Doesn't matter. I can then interpret the area percentage. Whew, laggy in my writing there. Change as an increase by 44%. Let's say here increase of or an increase by, whatever word you want to use there. Just interpreting the appropriate factor. I'm not calling it the scale factor because I want to separate these two, length dimension and area dimension, in my mind. So we have our headings here. We'll keep these pieces. And in the second one, they tell me the length percentage change is 80%. Now, they have to tell me, is it an increase or a decrease? Let's mix it up and go a decrease of 80%. They have to tell me, right? They can't just say, oh, it changed 80%. Yes, but is it up or down? I don't know unless you tell me. So let's mix it up and go down. Then the scale factor is going to be the decimal version of 80%, which is 0.8, down from 1, so I'll get 0.2. 2. So it's a big drop, which means my scale factor is far away from 1. That's okay. The area factor is still the scale factor squared, which you might feel it's a little small, but 0.2 squared 0.2 squared is in fact, oopsie, random line, going to be a very small factor when it comes to the area. Interpreting that multiple ways, I can say the new area is 4% of the original, or it's decreased by 96% to only be 4% of what it originally was. So as the factors and the percentages drift far away from my base 1, my base 100%, it does feel a little stranger, I suppose. But I just have to remember that I'm always interpreting it in the same way. Okay. So if I get a factor of 0.04, yeah, that's quite small, quite far away. My interpretation doesn't change anything. Often what I get, if I, just as a side note here, if I get a factor of 3, people often struggle to interpret this correctly. I'm still going from my base 1 up by how much? By 2. The percentage version of 2. So this is going to obviously be an increase. By what did it increase? It increased by 200%. And the new length is 300% that of the old length. My interpretation does not change. But as I drift very far, in some examples, from my base 1, people feel like something different has happened. No, nothing different has happened. So be aware of that. Next one. Let's number it. Oopsie. 3. There I'm given what is k squared as 1.2, the area factor. Now I can right away interpret the area percentage change, which is, of course, the area increased by 20%. Great. How did I change the side lengths to get that result in the area? Well, if k squared is 1.2, k is the square root of 1.2. That is something my calculator didn't tell me. Oh, hold on, I pressed strange buttons. And MathBot did not like that. I'm not sure where Discord disappeared. Am I still here? There I am. Seem to press. I've seen this random button. Discord was not happy with, and everything just stopped. I just wanted to do a square root, but apparently it said nope, no square root for you. I think we're good. We're back on, I hope, but let me know if I'm wrong. Just wanted to press 2 equal signs, and it said no. Let me try again. It's not happy. My equal sign apparently is doing a zooming shortcut. I don't know why. Let me just try and press random buttons. See, random buttons always work. So I'll do my square root. I'll show it in a second. And there we go. So the square root of 1.2, I'll just round to, let's say 2 decimals, 1.10. It's approximate, of course. But it's a final answer, essentially. So rounding is okay. At least 2 decimals. So that would mean, if you want to go more, let's maybe go more. Sure. Let's go 4 decimals. So that'll be 0.954. Sure. Then we have some digits to see. That means I am up from my base 1. So I did increase. It was an increase by 9.54%. And that resulted in an area increasing by 20%. So as I go forward from length to area, I square the scale factor. If I go backwards, I have to take the square root. And hopefully your calculator is pretty straightforward in doing that. Then lastly, we have a percentage change in the area. Again, they need to tell me, is it up or down? I don't know. Maybe let's try it down, because the ups are here already. So let's say the area decreased by 20, no, not 20%, 80%. Whew, that is going to be a big change. And then the area factor corresponds to that. Area factor is going to go down by 0.8 from 1, so it's going to be 0.2 in area. I have to find the scale factor first before I can interpret it as a percentage, so it'll be the square root of 0.2. MathBot did not like that because my T did not actually press. Minor problem. Okay, so 0.4472 if I round to 4 decimal places. That means, ooh, it's a decrease, not as big. The area has a more substantial change than the length dimension does. But I decreased by, well, let's just look at the gap here. Let's say here, 1 minus this scale factor will give me the gap that I went down from 1. It'll be 0.5528, right? So that then tells me I just need to convert this to get the change percentage, 55.28%. Yes, the new lengths are 44.72% of the original. They decreased by 55.28%. There's a difference in those two interpretation sentences, right? But we've covered that last time. All right, not too bad, not too bad. I wanted to see everything so that regardless of what a specific question might give me, it's just a combination of these. Some information will be given, and I can find the other information, percentage or factors from that. All right. So hopefully with some practice, I just need to remember the link. Whether it's going forward or backwards, the link is the same. Regardless of the size of these numbers, my interpretation in terms of percentages, that's also the same. Okay. So that ends our scale factor part of this chapter. The other half of this chapter is where we will actually now transform or look at transforming polygons. For simplicity, we'll stick to simple polygons. So let's highlight the 4 transformations that we need to be able to do. Just write them out, and then we'll slowly do them one by one. No rush whatsoever. Alrighty, so our, let's say, basic transformations. And in all of these transformations, I'm preserving the, let's say, aspect ratio of the image. It's a similar image, sometimes the exact same, sometimes an enlarged version or a smaller version, but it's always to scale. It's always some scale factor that is involved. Okay, first one will be, well, there's no real order. Some of these are going to be a little bit easier than others, but let's start with the scaling one, where I'm essentially zooming in or zooming out, scaling. Then I also want to do a translation, which is just a fancy word for shifting the image to a new position. So the image stays the same size and everything is just moving the image, the polygon. Then we want to look at a reflection. And lastly, we want to look at a rotation. Now, admittedly, in elementary school, for the most part, you work with grid paper, and it's quite basic in its initial introduction, but these concepts of how the original shape or picture or image is transformed is the same. So we are going to not go too extreme. The actual intention here is to only use a straight line and a compass, or straight line tools and circle tools to accomplish this. Now, in the case of scaling, you'll see that that's perfectly fine. But in the others, it gets a little tedious. So we are going to exploit the additional tools that GeoGebra has, but one thing at a time. Let's do the scaling first. Each one of these has its own set of steps, its own sequence of steps that I would have to memorize. Let me just check my window size, that it's good, and we can see as much, we can fit as much in as we can here. Let's say that looks pretty good. Okay. So now we're going to take a polygon. Let's keep it simple. Let's take a triangle, like that. If I have a larger polygon, nothing is going to change except the time it takes me, because there's going to be something that I just repeat for every vertex. Okay. So what I'll be given is a polygon, or I can draw my own triangle maybe, and a point. Let's pick this point over there. The point can be anywhere, but for our first example, let's put the point over there, outside the shape. What I want to do, I have to be given a scale factor. So I don't know if I actually have an example here. Let's suppose, yeah, I'm going to pick my own triangle, but let's work with example 1 or 12.2 here. Zooming enough, okay. Without looking ahead, I want to scale my shape, Could be a quadrilateral, could be a triangle, whatever, doesn't matter. I'm going to do it a couple of times anyway, so let's pick a triangle. I want to scale it by a scale factor of 1.7. They have to tell me either the scale factor or the percentage. One way or another, it's the same thing. So in this case, I want to have a scale factor of 1.7. So I have to remember 1.7. Okay. That's going to tell me how everything is going to enlarge. I'm just going to move, let's move my point out a little bit further. Doesn't really matter. Let's put it over there. It's fine. It's fine. Okay. So what I am going to do is make a line. I can make it through each of the points to the center. I'll call this the center point because it's going to be the center of the new shape. I'm going to sort of zoom it because my scale factor is 1.7, right? So it's going to be a larger triangle than the original one, and it's going to be positioned according to this new point D. All I have to do is measure for each of these lines that I made, AD, BD, and CD, one at a time. Let's go AD. I have to measure AD and then multiply it by the scale factor, and then we'll see what we do. So first of all, I need a tool here that can measure a length. I have in my measure category distance or length. Distance or length. So it says when I click on it, let me just check if we can see that. And I want to go slow enough. We have multiple days for this. There is no rush. We can't see it. Can we? If I click on it. Yeah, it's at the bottom there. Okay. It says select 2 points, a segment, polygon or circle, and it's going to give me the distance. Now, just to make things simpler, I'm going to help us remember that we're only doing it for this first line segment. So let's pick the distance or line. I pick A to D. It's going to tell me this length AD is 7.5, whatever the units are. Doesn't really matter. 7.5 units. Next, I need to multiply that by the scale factor. Let's do it in our calculator. And 7.5 times 1.7. 7.5 times 1.7. So then, this is my center. I'm going to measure everything from the center D out. From the center D out. I'm going to move things a little bit. I now have to measure from D a distance of 12.75 further out towards A, but it's going to be past A over here somewhere, right? So I don't necessarily have this distance length tool measures an existing line segment. Can't really use that, but I can do a circle of a specific radius. So let's just see which tool that is. Circle through a point. Select the so the second tool here. Circle, center, and radius. If I give it the center, which is going to be D, and I draw a circle with radius 12.75, then wherever it intersects this AD extended line, that's going to be the length from D that measures 12.75. Because I'm sort of restricted to my tools here, right? I don't have a ruler tool. I have a straight line tool and I have a compass. So I'm going to pick my center point, D. It's then going to ask me, what do you want the radius of your circle to be? I want it to be 12.75. And it draws the circle. Very big circle. I only care about this point that now is created there. Point E. Once I have point E, I don't need to see the circle anymore. It's not relevant. I have that. This is going to be the new position of the transformed point A. I'm going to make a new triangle over here. It's going to be 70% larger and sort of shifted in the process. And the new position of vertex A is going to be here at E. This is going to become more clear as we do the same process for the others. Now, because I'm thinking about a test, I'm thinking ahead, I want to use the distance or length tool and just label this new distance that I measured and confirmed, okay, it's going to round it to 1 decimal place. I can't control that, but just confirm that, look, I am aware and I'm showing that my distance is the scale factor multiplied with this original AD distance. I can't help GeoGebra's rounding. So now I'm going to do the same thing for my next line. From the center, I know it doesn't look like a center, it's the center of that circle. It's called the center point through my next vertex, B. Let's just move up a little bit. I want to take my time here. So I understand the process and I can follow along fairly well. But maybe it needs some practice, right? It's up to you eventually. First, so I make my line. Now I need to measure how long this distance BD is. So I go to my measure section, distance or length. D to B is 10.6. Then I'll go to my calculator and say, well, I have a scale factor of 1.7. I'm going to apply it to this 10.6. So 1.7 times 10.6 and get 18.02. So now I need to measure a new length, 18.02, from the center past B somewhere over here. I can do that by specifying a circle centered at D with that radius. Circle, center, and radius. I want it centered at D. What's the radius? 18.02. Zoom out a touch. That gives me my new point on this extended DB line called F. I'm done with the circle. I don't need to see the circle. For my immediate purposes, I will show it if I have to submit it for a test, but not right now. I do want to measure line DF for testing purposes to just confirm what the length is, because me as the instructor, I don't want to go and measure your lines every time. That's going to slow me down a lot. And as it is, I take too long to return the tests. Don't make me take longer. Let's position these guys just so I can see everything. All right. So this F point is going to be the transformed B. I'm going to make a bigger triangle that's 70% larger in side length. And it's going to be shifted as well. And that's positioning is going to be based on the center. We're going to change the center for our next example so you see the result. So I need to do the exact same thing, but now from the center through C. So I do the same thing over and over and over. If you had a quadrilateral, you would do it 4 times. If you had a pentagon, you would do it 5 times. If you can do it a few times, increasing that number is not really groundbreaking. So now I'm going to move so I can, these things aren't labeled, but I just want to get it out of the way here. I am going to have to measure my distance DC. And currently DC is 6.8. Great. 6.8. I need to scale that according to my scale factor of 1.7. So I'll multiply 1.7 by 6.8. And I apologize if you can hear the truck outside. There's really nothing I can do about that. I guess I could close the door. Then I get 11.56. So I need to measure from D, and as I'm speaking, the truck just gets louder. It's lovely. not distracting at all, but hopefully my microphone is good enough and you can't hear anything. I'm just talking about a random truck. You have no idea. I have to measure from D a distance 11.56. I can do that with my circle that needs the center and a radius. I want the center to be D because it's called the center for that reason. I want radius 11.56. That then gives me a new point where that essentially measures the length that I was looking for on that extended line DC. Don't need to see the circle and confuse myself. I was just looking for the point. I do want to label it to indicate that I have the correct distance, at least rounded to one decimal place. I don't like it on lines. Just move a little bit, buddy. Just move. Just a little bit. There we go. 11.6 is the rounded version of 11.56. But in the background, it is measuring it correctly. It's just not labeling it. So the labels don't get too big. Now I am essentially done. I just have to draw my new triangle connecting these new transformed points. It's not going through B, it just overlaps depending on where the center was positioned. There is my new triangle. Scaled, zoomed, enlarged by way of a factor of 1.7, a scale factor, so that means the side lengths have increased by 70%. Maybe I want to hide these lines too, so I can just look at my end result and be proud of myself. The fact that they just touch there a little bit, it's really just because of the positioning of D. If I pull D a little bit further out, this one would drift a little bit further out as well. Now, of course, this isn't what I submit. I want to show everything and then save that and submit that, of course, in the same way we have discussed previously. All right, so I want to take my time here. Take my time. Because in the past, people struggle with this. Make your own list of steps. As you watch the video afterwards, maybe write down your steps. We're going to do it again, but make the steps for yourself. It is in the book, yeah, sort of, but don't feel too restricted by the book. If you want to put it in different words, then do so. Essentially be the same, right? So here we have a quadrilateral. We pick a center there. We draw a through line from the center to a vertex. We measure it. We multiply that by the scale factor. We measure that from the center, always from the center. And that's the image, the new point, the transformed vertex. And I keep doing that for all of them. And I get the larger, in this case, 70% larger in side length, quadrilateral. Okay. But I do want to show what happens if for a different center position. Now I'm going to stick to a triangle. Really, I mean, there is no benefit in me doubling up my work further. I'm already going to do the same thing 3 times. Doing it 4 or 5 times really proves nothing. So a triangle is perfectly fine. I'm going to put the center maybe over here, inside the shape. Let's see what happens. I'm going to pick a scale factor. I'll write it down in the chat. We're going to pick a K. Well, let's zoom. Let's make it smaller. Let's say 0.6. Doesn't want me to type. There we go. There's a scale factor. Evidently a capital K, but whatever. K is K for us here. K is 0.6. That means everything's going to decrease by 40%, right? Decrease by 40%. Now, that's just my interpretation, that the 40% doesn't actually play a role directly. My method is going to be the same. I'm going to pick a vertex. Let's pick A. I'm going to go from my center through A. Now I can only do it both ways, but whatever. I'm going from the center through to one of my vertices. It's okay, yeah. I'm going to have to measure distance or length this line segment DA. DA is 4. Oh, that's nice. That's a nice number to work with. Let's put it as high up as I can. So then I'm going to apply my scale factor to that length. So 0.6 times 4. I know you know what it is, but I'll show it anyway. And my new length that I need to measure from D, always from the center. Always from the center. So important, I'll say it again. Always from the center is 2.4. I'll do that by way of a circle by specifying its radius. I want my center to be D. What's the radius? 2.4. Or a little tiny circle. The circle is temporary. The point is what I'm looking for. And because I'm going to have other circles eventually that I don't want to necessarily see, don't want to see that. Maybe I don't want to see the line either, but I will see I'll keep the line there. Needed that point E. Now for clarity in my answer in a test, I'd like to measure DE to show the label. Like so. Just to show, okay, it's what it should be, rounded to 1 decimal, which is automatic. Okay. Now I'm going to do the exact same thing, but I'm going to do it for point B. Could be next. Which means I'm making a line from D through to B, and then I need to measure it. Distance or length is what I'm measuring D to B. It is 8.5. You might want to reposition these guys. Maybe, maybe not. I don't know. 8.5. So I'm going to apply the scale factor to that length 8.5. Scale factor is 0.6. 0.6 times 8.5. And we get 5.1. That's the length I need to measure from D out towards B, 5.1. Circle by specifying the center and radius. I can do that. Center is, of course, D. It's called the center. And I want a radius of 5.1. There it is now. I want my label just to maybe just not cover it. That gives me a point. It's automatically called F. And I want to measure this distance DF so that I can get a label and show. Look, I measured it. It's what it should be. I will hide my circle because it was a means to an end, and I've reached the end for that point, that vertex. I will now do it again a third time for point C. So a through line from D through to C that I have to measure. I will measure it. It is 5.7. I then apply the scale factor to that 5.7. Our example scale factor is 0.6. 0.6 times 5.7. And that means we need to measure a distance from D 3.42. 3.42. I can do that with my circle, center and radius tool. Center is D. What radius do I want? 3.42. It'll measure it exactly, but it won't label it necessarily. Now I am in a little bit of a pickle here. This label is too close to where I want to work, so I just move it. No big deal. I want that point G, and I don't want to see my circle anymore. It's done. When I have too much on the screen or on my page, it just gets a little crowded and distracts me from what I'm trying to do. That's the downside to doing it on paper. Like I can't necessarily erase stuff very easily. I have to look at all of it. This, I can hide things and everything's there. I will show my work eventually when I'm submitting it. But when I'm still busy, I want to focus on what I'm doing right now. And it helps to hide things. Whoa, should not have done that. My apologies. I can't move the polygon parts of it, then it transforms the whole thing. So I want to just, when I move stuff, I want to move in blank white space. Alrighty, that looks pretty good on my screen. Now all I have to do, maybe I want to hide these things now. Maybe see those lines. Their job is done. All I have to do, and I will show them eventually, is make line segments to form my transformed triangle, like so. I could have actually made it. I could have used the polygon tool actually. We'll just make it a little bit more colorful and shade it in and all kinds of stuff. It just looks a little nicer. And I'll show and hide one last time. Maybe zoom out a touch. Just a smidgen zooming. Look how nice that is. And I've created a triangle that is 40% smaller in length than my original. And you can see here, you can have a visual check. How do I know if this is right? Well, I don't know for sure, but visually, I can see that the corresponding sides are parallel. See, the spacing here between these sides are always the same. Spacing is always the same. They're parallel. If you look at it, and one, I don't know if I quickly do that. One maybe some lag. Come on, move. Can't move it? Okay, fine. One maybe looks not parallel. The gap is closing on one end. Then something went wrong in the calculation. Not all your side lengths, when you scale them, are calculated correctly. Something small went wrong. So if you look at this and you see, oh yeah, everything, the corresponding sides, these gaps look parallel, looks good. It's not a guarantee that it's right, but probably is. So I can use that to see if I'm sort of on the right track, especially if I hide everything. Good. It looked pretty good. Pretty good. And then I can submit that and feel good about myself. Good job. So that was one transformation. I don't want to rush these. I want to have to go through it slow enough so you can look at the video, or if you've done it in real time, write down steps for yourself. By the process of writing it down for yourself in your own words, that's going to help you remember. That's going to mean way more than looking in the book. I need to have something in the book, but I prefer this in your own words, especially the other transformations. Do it in your own words. Write down the steps. There aren't many steps. And if you don't remember the steps, watch the video again, especially the second one. I think maybe the steps were a little bit more clear. Write them down. Step 1, okay, he did this. Step 2, did this. Write it down for yourself.